Welcome back to the another session for the solving of the problems with previous year question for the open system one. This is the fourth question, and all it is for 17th question in the first law, that is unit number 2. Let's read out this question, which has been asked in June 2014 for 10 mark per question. Let's read out the question and try to solve it. In a steady flow system, the fluid flows at a rate of 5 kg per second, that is mass flow rate is given. It enters at a pressure of, state 1 conditions are 620 kilopascals and velocity as 300 meters per second and internal energy as 2100 kilojoules per kg and specific volume as 0.37 meter cube per kg. It leaves the system at a pressure of 130 kilopascals. This is at the state 2 conditions and velocity of 150 meters per second. Internal energy is 1500 kilojoules per kg and specific volume as 1.2 meter cube per kg. During its flow through system, there is a heat loss. On the spot, there is a heat loss which is d dash q by dt is given as 30 kilojoules per kg, and the next is heat is lost, so it will be a negative, which is given per kg, which is in terms of the mass. And next is determine the power capacity of the system in kilowatts, that is we need to find it in terms of rate. State whether it is to or from the system. Okay, and next is neglect the changes in the potential energy. This is the question which has been asked. Okay, so let's this is very simple question which is not so difficult to solve. Let's try to write the given data which is at the state 1, state 2, and draw the sketch and write down the formula of your steady flow energy equation and then substitute the values, and then we'll try to calculate. Okay, so let's start first with the given data. Given data at state 1, which is P1 is equal to 620 kPa, V1 is equal to 300 meters per second, and U1, the internal energy, is 2100 kilojoules per kg, and the specific volume V1 is 0.37 meter cube per kg. And next, it's state 2. It's state 2. The properties are P2 as 130 kPa and V2 as 150 meters per second. And next, U2 as 1500 kilojoules per kg, and the specific volume at exit as 1.2 meter cube per kg. And also it is given like d dash q by the dm as 30 kilojoules per kg. Okay, so to find what is we need to find power P. Okay, so what are the assumptions which we are trying to make it over here? The steady flow, and another assumption is neglecting the potential energy changes. Okay, so let's try to draw this sketch. It's very simple. Control volume, this is at state 1, the properties, and this is at state 2, the properties. Okay, so here what is the power which is we need to calculate. Okay, so next let's try to write down the formula. What is the formula which is given here? D dash q by dm, steady flow energy equation, plus h1 plus v1 square by 2 plus zz1 is equal to d dash w by dm plus h2 plus v2 square by 2 plus z2. Okay, so here what is we are neglecting here? Potential energy changes we are neglecting. This is 0. Okay, so now let's try to simply substitute the values and then we'll calculate the power. Okay, 30 kilojoules per kg, which is the value into 2329.4 plus 300 whole square by 2000, because 2000 is written by converting it to kilojoules one, is equal to 1656 plus 150 square by 2000 plus d dash w by dm. Okay, so here as we know, h1 is equal to u1 plus p1 v1. So here it is equal to 2100 plus 620 into 0.37. That gives the value of 2329.4 kilojoules per kg. Okay, and similarly h2 is equal to u2 plus p2 v2. It is equal to 1500 plus 130 into 1.2. So we got the value as 1656 kilojoules per kg. Okay, so now let's try to calculate the work. D dash w by dm is equal plus 1667.25 is equal to 2404.4 d dash w by dm can be written as 2404 minus 166.25. So finally I got the value as 736.15 kilojoules per kg. Okay, so here finally the mass flow rate is given as rho a1 v1 is equal to a1 v1 by v1. So this is equal to 5 kilojoules per second, which is given. So from this d dash w by dm into dm by dt is equal to d dash w by dt is equal to kilojoules by kg into kilojoules per second. So finally you'll get the value as in terms of kilojoules per second, it is equal to kilowatts. So finally d dash w by dt is equal to 737.15 into 5. So therefore finally you'll get the value as d dash w, the rate is equal to 3685.75 kilowatts. So this is the final answer which I got. Okay, so this is positive work is done on the system, positive work. Okay, I hope this solution is clear. Let's move on to another problem in another session. If still you have any queries, you can ask me.